right. Well, today we're gonna hear Isaiah talk about some of his PhD research. Isaiah is from Sabisky, Wisconsin. Anybody know where that is?
Wisconsin.
Oh, look at that! I'm impressed. It's at High Green Bay. And then he got his bachelor's degree at Stevens Point, and then went to Montana Tech for his master's degree. So he came here to work, and he's going to talk about part of his research.
Thank you, Dr. Howe, for the introduction. I'm going to talk about, like I said, a small portion, not really small, but it's maybe a third of the overall project. Specifically looking at various cover crops, their abilities to protect soil and the environment and provide forage. So it's fairly well known that cover crops have a lot of benefits both for protecting soil and the environment. They cover the soil surface, which helps hold the soil in place. And by reducing that erosion, helps to control some of the mobile nutrients like phosphorus that has a tendency to move with soil as soil moves. The plants themselves will assimilate nutrients, making more mobile nutrients like nitrogen that have a tendency to move with water and hold those in the soil as well, preventing them from leaching into groundwater and ultimately to surface water. And then the biomass can be incorporated in the soil. The root biomass is present in the soil, which helps to build soil carbon. Yet in the United States, implementation of cover crops is very, very low. About 5.1% nationally, with the most significant or the highest level of use in pretty much every county is above 15%. This area around the Chesapeake Bay. That's because that particular area is regulated the amount of phosphorus that's allowed to come off of farmlands into the Chesapeake Bay. So the cover cropping ends up being very important to those farmers to reduce potential fines for letting phosphorus to that water body. And then the area of Texas that we're looking at, it's far lower than the national average. With some counties getting up above 1%, and most of those, about half of those, close to zero. So when we look at some of the national surveys regarding cover crops, there are some major concerns that come up pretty much every time when we talk to people. First one being, and probably the biggest one, a lack of economic return. Cover crops are expensive to plant, and generally speaking, they're not a crop that are going to be able to be sold for any particular purpose. So right off the bat, the lack of economic concern is a big issue for a lot of farmers. Long-term, building the soil health and like a 10 to 20 year time frame, they might receive some return from that. But in an annually required purchase, they need a little bit more of an immediate return to accept that cost. And there's a fear of yield reduction from the subsequent cash crops, as well as particularly in some arid regions, concern that it's wasting soil moisture that's really necessary for getting that subsequent crop established. So when we look at some of those concerns for economic return, they are expensive. The lowest literature value that I found for a cover crop was about $4 per acre. And the highest was actually the cost of one of our treatments that was approaching for this year's planting about $75 per acre. And one of the ways that we could start to recoup some of that crop or that cost is using them as a forage for cattle. Now, foraging, particularly on lands that we expect to be able to produce row crops, has some potential damages, with the weight of the cattle being a concern for compaction of the soil. And so to mitigate some of that effect, we're really looking at things that are good for flash grazing. And this flash grazing, that large number of livestock in a very small area of land for short periods of time, typically less than a day. And by doing that, that can minimize some of the damages of having cattle on otherwise arable land. And so when we look at some of the literature related to yield, related to or on wild cover cropping, it's a 2018 study in Lubbock where they're looking at cotton yields under two different coverage crops, one using cereal rye and the other mix that was cereal rye, dairy, veg, winter pea, and radish, and comparing those against the conventional system. And in the first year of that study, they had no differences between the conventional system and cover crops with regard to yield. But in the two subsequent years, the cover crop where they were using just that cereal rye, it was cotton lick yields were significantly lower. But when they added the legumes to that mix, there's no significant difference then again between the cover crop and the conventional system, which is kind of getting at the point that using legumes that fix nitrogen, keep more nitrogen in that soil profile, that is then re-released at a time that those plants need it. And so including legumes as part of the cover crop mix is probably going to be fairly beneficial. And when we consider the concerns with moisture, this is another paper from basically the same study, looking at the same mixes. This is an irrigated cotton system, and we have 0 being the day that the cotton is planted, and just before that day, the warm colors are lower soil moisture storage, and the cool colors are higher storage. Pretty much each year, the cover crops have a little bit of a dip before they get ready to plant, which if this went back further, I would guess is probably a dip throughout that growing season. The cover crops are in the soil. But when they get ready to plant and that system is irrigated, the amount of water comes back up. And in the systems that have the cover crops, that water storage is actually higher than the system that doesn't have the cover crops. So when it comes to concerns about moisture in some arid environments, it's possible that cover crops are actually more helpful. There's another study that was just published in 2021. This was looking at a warm season cover crop, and they saw a similar sort of effect where during the growing season that moisture was reduced, but then right when they're getting to planting, in this case it was winter wheat, the moisture with those kind of late summer into fall rains bring that soil moisture back up, at least to a point where it was sufficient to cover the crop. And in a couple treatments over a couple of years, there were a few of them where there was no significant difference between the cover crop and the conventional system. So when I'm looking at two major objectives for this project, evaluating the cover crops, different mixes for their ability to be flash raised, specifically looking at their ability to cover the soil, to restrict weeds, and then comparing a group of different crops and the amount of forage biomass that they can produce, along with the quality of forage that they can produce. And the second one was to ascertain the effects of cover crops on soil health and plant available water. For the sake of this seminar, I'm going to be focused mostly on that first objective. And so we ended up isolating to 21 different treatments. One of those is our fallow, sort of conventional control. And we planted them in two different locations, the Texas A&M Research Farm in Snook, was planted in Belle Clay, and then at the Stiles Farm over in Burleson Clay. And then it was an RCBD with 4 replicates using, for this, all the statistics are in LSD, the alpha of 0.05, We're looking at 4 major criteria to evaluate the ability to be both good cover crops and good forage crops. We're looking at first, we want high biomass to provide some of that protection of the soil and provide something that could be grazed. We're looking for good cover of the soil. We're looking for reduced cover from weeds, as well as a high relative feed value. So out of the 21 original treatments, for this, we're focusing on 13. Several of the treatments that we used included rape in the mix, and we found it very hard to terminate that rape at the end of the season. So being that rape was then turning into a weed in the subsequent crop, we figured that wasn't going to make an overly good cover crop. So I'm just pretty much cutting that out of the presentation, also to make some of these plots a little easier to look at. 21 bars in a plot is way too much. The other treatments that I'm not including in this were treatments that use native plants as potential cover crops, and they just really didn't perform well last year. This year they're doing a little better, but last year they did not perform well. So that's when we looked any different than our fallow treatments, so I didn't include those either. But what we are then including is that fallow and conventional control, and then a group of small grains, looking at fast track rye, mostly because there's promise with that variety to produce a lot of biomass quickly. Albon rye as a more conventional cereal rye, triticale, barley, and then a small grain mix that's about 50-50 oats and fast track rye. We're looking at a small group of legumes, just a mix of biomaster pea, frostmaster pea, and hairy vetch, and then also hairy vetch on its own. And then mixes of those small grains and legumes, varying the amount of small grain to legume, and then varying a little bit the variety of legume and small grain. So to assess biomass, we put out 1/4 square meter quadrants. We clipped all of the biomass within that quadrant and air dried it. And then I calculated those up to megagram per hectare sizes. And what we ended up seeing here was, at least with most of our mixes, there's not a lot of significance. Once we get into, at least in stuff points, so we got into some of those monoculture treatments, we didn't produce as much biomass. But at least in our numerical top 3, we have our 50-50 oat rye legume mix, barley, and oats rye and snook. In thrall, things performed a little bit more evenly, but our numerical highest were the 20-80 oat rye legume mix, and then the oat rye mix and the barley again. And then we had that 80-20 mix showing up shortly behind, and the barley and vetch mix coming up shortly behind those as well. Then to get an idea of weed cover, there's a note that I wanted to make on this one. I ordered these bars in order of most to lowest biomass, and for the rest of the presentation, I focus on and keep them in that order, just so we can kind of see how the different parameters we looked at compare against that biomass potential. So when it came to getting an idea of both the crop and weed cover, we put down the same quadrants. And this time we just did a visual estimation of the percent cover from that cover crop, percent cover from weeds, and from there, kind of the differences, or the difference from 100% is approximately the percent bare soil. And when it came to that ability for the crop to cover the soil, we have pretty even across the board, not a lot of significance. After all, we had a little bit of a dip with some of like the fast track rye and triticale. That 80-20 mix was a little low. And then in snook, we had really the vetch here did not perform well. It was not significantly different from our fallow treatment. But then in thrall, that vetch was numerically the highest treatment that we had. It's just kind of variable depending on weather. When we look at the weed cover, it's almost a complete analog of that. When the plants have the ability to cover the soil, they're going to shade out the upcoming weeds. So we had very high weed cover of the fallows and thrall. If you went out there and looked at those plots, you would swear that we planted henbit as one of our treatments. It was just like a complete cover of henbit over our fallow plots there. And the weeds weren't as bad in snook. And once again, the vetch really didn't perform any better than the fallow. And then when we're trying to account for that relative feed value, we took some of that dry biomass, ground that, and sent it to the soil testing lab. And they analyzed it by near-infrared analysis. And then we got the relative feed values. And about part of that relative feed value is protein content. And so the mixes that had legumes in them tended to have more nitrogen available because those legumes are fixing nitrogen, which gave them a little bit more protein. So they have that little bit higher relative feed value. And so the legumes, and then very little significance throughout the mixes that included legumes. And then once we got into really the Elbon rye, triticale, and that oat rye mix, that was one of our best biomass producers, we got to those being very low in regards, or at least significantly different from the ones with legumes in them for that relative feed value. So when we look at which ones, trying to determine from that which cover crop mixes that we're looking at perform the best, the highest biomass producers were where we started, at that 20 to 80 small grain mix, 50-50 small grain legume mix. The barley and the oat rye being the top three from both sides. But then when we consider that relative feed value, that oat rye being significantly lower than the other treatments and being the lowest treatment that we tried altogether, we dropped that out. And so that 20-80 small grain mix, 50-50 small grain legume mix, and barley being our best performers with respect to both being an effective cover crop and producing the highest quality forage possible. And from there, we conclude that of all of the mixes that we tested, they all provided some sort of cover for the soil. They all were able to reduce weeds. They all produced biomass with regards to protecting the soil. Having a cover crop there was better than having nothing at all. And so they all did fairly well. Then when we start talking about and getting into some of the forage quality and that feed value, the need for those legumes become a little more apparent, especially the peas helping to improve that relative feed value. And so future work, one of the things we're trying to do this year, this being the second year that we're doing this project, it is to evaluate whether or not some of these can be grazed multiple times. A lot of the legumes do not regrow quickly after the removal of the meristem. So once it is grazed, you have a tendency to not be able to graze those again within a season. But some of the small grain crops, as long as that basal crown isn't damaged, they tend to regrow fairly quickly. So that may kind of provide a little more differentiation between the two groups. And then really looking at over time throughout the season, which ones can produce more biomass more quickly versus looking at a single time point this season. And then really getting at that second objective, trying to get an idea of how these affect soil health and plant available water. There's a lot of literature out there to support those effects. We do want to confirm that we're going to say these are good, they actually are providing those same benefits. So we need to test bulk density, soil moisture, fertility, and organic carbon. I currently have 1,680 samples that we took last season that are in various stages of being analyzed. And at the end of this season, in the next few weeks, I have another not quite 700 soil samples and a little over 150 plant samples to take to continue that second year of research. And then just wanted to acknowledge my committee and the various student workers that helped to get all of these samples taken and prepared for analysis, as well as the NRCS that provided the funding for the project. Then I'll take questions.
So you mentioned the natives did not perform well. Where is that published?
I haven't really, there hasn't been much work done with them as a cover crop yet. So it's just that one season last year that they did not perform well. We're looking at the little barley and deer pea vetch. And the deer pea vetch really never established, and the little barley did eventually kind of catch up, kind of getting into May. This year they performed somewhat better, they established more along the same time frame as the other crops that we produced. So just for today's sake, I didn't really talk about those.
I wasn't. My concern is that the literature that's been published on cover crops is almost always when they work and never when they don't work. And it's more important or as important for people to know what doesn't work as to what does. And we've been notorious in cover crop literature for only publishing the good results.
Now that is one that I hopefully would like to include in publications with the rest of this work as a part of the mixes that we tried. It is, I mean, negative results are just as important as positive results. I strongly agree that it doesn't make sense to not publish negative results, that people keep doing it over and over again and then not publish it. So.
I find it pretty striking that the veg was so different in both sites. What sort of environmental things do you think played a role? Was it soil, weather, is it management?
They're managed relatively the same. They're both planted in very similar soils. I think water probably a lot to do with that. I mean, we're all got a little more rain that year. That's the biggest thing that I can come up with. That's probably that we're all got more rain that year.
From the price range cost per hectare, which one do you think is the sweet spot? Okay, Mr. Williams.
I don't have a lot of the economic stuff done yet, but in terms of the mixes that performed well and the cost likings tend to be more expensive. So out of those handful of mixes, the 20%. So the 50-50 small grain the legume mix is probably going to give the most benefits per cost. It's going to be a little cheaper than the 20% small grain to 80% legume mix, just because the small grain seed is a little cheaper. It still has that legume as part of the mix, providing a little bit more of that nitrogen forage quality.
Sure, that's a question.
The question is, what were the major weed species if you see weed cover crop interactions in a particular cover crop more than others. For the most part, the weed species were henbit. Really, it was the only one that was worth noting. And it pretty much, I'd say, was fairly equal amongst all of the different treatments. Where there wasn't cover crop, there was henbit. There was exposed soil, henbit was growing.
Questions?
Nice presentation. Did you look at the soil moisture during the cover crop period, or did you look at when that is incorporated to the soil during the crop period?
So I have the samples, I have some of that data, and I'm still working on getting all of that data processed.
Other questions?
Is there might be more animal science, but is there like palatability studies on most of these crops if you look at the cover crops?
There's some,
Do they vary much?
from what I've seen, there's, I don't know, if you've looked at this one, the legumes tend to be more. Speak to off the top of my head.
Would a grower that implements one of these mixtures need to expect like additional fertilizers, additional applications of herbicides? Like what does the economic cost entail, beyond just the seed?
Generally with the cover crop, one, we're trying to reduce the amount of nutrients lost. And it's not a cash crop. It's not necessarily something that's looked at as being profitable. So you're going to try to do this as low input as possible. So we did not fertilize any of these. Some of the small grains, depending on what's left in the field, may struggle without the legumes just because of the lack of nitrogen. So you shouldn't really be looking at adding any additional fertilizer costs, but they do need to be terminated usually about 2 weeks before planting, so they have enough time to start breaking down and re-release some of those nutrients, as well as allow some of that soil moisture to rebuild. And so that can be done mechanically. It's not always the most effective. So there's some herbicide costs that's going to be more.
How do you plan on tracking your rates of mineralization between different groups of cover crops?
So I don't necessarily have a plan to track rate. I am looking at change from season to season of nutrient concentration within soil. I have a particular plan to track rate. I would probably just do an incubation study with some of the testing.
Any more questions? All right, let's thank our speaker.